Class 8 Science, Chapter number 4, Force and Pressure. My dear student, let's start the session with the prayer. Are you ready for the Gayatri Mantra? Let's start. Om Bhur Bhuvar Swaha Tasya Viturvarenyam Bhargo Devasya Dhimahi Dhiyo yana prachodaya. The meaning is, we meditate on that most adored Supreme Lord, the Creator, whose divine light illumines all physical, mental and spiritual being. May this divine light illumine our intellect as well. Do you remember Ravi and Arun? We met in the previous PPT. Now, teacher gave the same task to both of them. What they have to do? They have to put nail in the wall. Now, how Ravi is doing that work? Ravi hammering the nails pointing side is facing the wall. Whereas Arun is doing the same thing just in the opposite way. And what happened after that? Ravi successfully can able to complete the task given by the teacher, whereas Arun unable to do that work. Why? You know something? The pressure given by Ravi is more the pressure exerted by Arun. But why so? To understand this thing, we have to study pressure in detail. So let's start part 2 of lesson number 4, Force and Pressure. Now, in this part, we will be covering what is pressure. That is the definition of pressure, application of pressure in our daily life. In some instances, we are reducing the pressure. In some instances, we are increasing the pressure. Then we will be studying about liquid pressure. You know, another name of liquid pressure is hydrostatic pressure. Then we will be studying about properties of liquid pressure or hydrostatic pressure. After completing this much, we will be taking a small break. We will be performing an icebreaker, that is simply a breathing exercise. Then we will be studying about atmospheric pressure, pressure exerted by atmosphere, air. Then application of atmospheric pressure. Finally, in this chapter, we will be doing recap in a different way. I already prepared a mind map for the entire chapter. You have to go through this mind map and then you have to perform the conclusion activity given at the last. So are you all ready for the chapter? We are now familiar with the effects of a force on different objects. Careful observation and analysis reveal that the effect of a force also depends on the surface area over which the force acts. It is a common experience that it is difficult to carry a school bag when it is tied to a narrow thin string. It is become easier to carry the same school bag when it is tied to a broad strap. This implies that if the same force, or say the weight of the object, act over a small area, its effect is felt more. Thus, the overall effect of a force depends on 1. Its magnitude, 2. The area over which it acts. We therefore need to define a physical quantity that takes both these factors into account. Physicists have now defined such a quantity and named them as pressure. It is pressure which is a measure of the effect of force over a given area. When we apply a force in a direction perpendicular to the given surface, that means 90 degree to the given surface, we call it a thrust. The thrust acting on a unit area of a surface is called pressure. Now look at the picture 1 and picture 2. In picture 1, the surface area is more in compared to picture 2. So, in picture 2, the pressure is more. Yes, the pressure is inversely proportional to surface area. So, in picture 2, the pressure is more in compared to picture 1. There are lots of applications where we are increasing or decreasing pressure as per our convenience. Look at the example here. The tanks and bulldozers are fitted with caterpillar tracks rather than wheels. So here, more the surface area. So when the surface area is more, the pressure is less. Yes, they are inversely proportional as I told you earlier. Whereas when we are cutting the vegetables or fruits, we have to reduce the surface area to enhance the pressure. So less surface area, more pressure. These are two examples of application of pressure in our day-to-day life. Now coming to a most important concept, that is liquid pressure. Another name of liquid pressure is hydrostatic pressure. Now, hydrostatic pressure is pressure exerted by a stationary liquid. To know the characteristics of hydrostatic pressure, let's perform two activities. Activity 1. I have taken a glass full of water and I make 3 holes at different heights. Now, what we can observe? We can observe the hole at the bottom, the water coming out and covering the maximum distance, and hole at the top is covering the minimum distance. In activity 2, I have taken a glass and I filled the glass with water. I made 2 holes in the same height, and what I observe? I am observing the water coming out from both the holes covering equal distance. Based on these two activities, we will be knowing or we will be concluding about the properties of liquid pressure. Clear? Dear students, based on the two activities conducted in the previous slide, we can conclude 3 main properties of liquid pressure. First, liquid pressure increases with depth. That means the water or the liquid present in the bottom is having the maximum pressure than the water or the liquid present on the top. Second, liquid pressure remains same in all direction at a given depth. That means if you put 2 holes in the same height, the water will be traveling or the liquid will be traveling the same distance. Third, the liquid pressure depends upon the density of the liquid. That means more the density of the liquid, more the pressure. Here we have taken 2 liquids, one water, another cooking oil. As we all know, water is more denser than cooking oil. So the pressure exerted by the water is more than the cooking oil.
A wooden block kept on a table exerts a force on it, and we know that the wooden block is a solid substance. What about liquids? We know that liquids are kept in containers. Do liquids or fluids exert pressure? Yes, they do. They exert pressure on the base and the walls of the container in which they are enclosed. The pressure on the base will be downwards, and on the walls, the pressure will be sidewards. We can also derive something interesting if we look at the fluid in terms of layers. Say there's water kept in a plastic container. Let's divide the fluid into 5 equal parts. You can see that the second layer of water is holding the weight of the first layer. Similarly, the third layer is holding the weight of the first as well as the second layer. And the fourth layer is holding the weight of the top 3 layers, and so on and so forth. So clearly, the pressure at the bottommost layer is the maximum. There's even a way you can find this out. Near the topmost layer, Make a little hole at the side. You'll see that the water flows out from that hole like this. It doesn't roll along the walls, it flows out at an angle. Now let's make a second hole near the layer under it. You'll see that the water flows out at a wider angle as compared to the earlier case. We continue to make holes in the wall and we'll notice that the water literally squirts out. This proves that the pressure at the bottom is much more than the pressure at the topmost layer.
Now student, let's take a break. Pause the PPT for a while and play any of your favorite song and dance at least for 2 minutes. Now start. I hope you all have enjoyed your free dance session. Now sit straight. We will be doing a breathing exercise. Inhale for 4 seconds. Hold for 7 seconds. Exhale for 8 seconds. Inhale. Hold. Exhale. Do this at least for 5 times. We all know that there is air all around us. It is the Earth's gravitational pull that holds this air around us. This envelope of air around the Earth is known as atmosphere. It extends up to nearly 1,000 kilometers above the surface of Earth. The weight of this huge mass of air exerts a pressure at all points and at all objects on the Earth. We call this pressure as the atmospheric pressure or air pressure. So atmospheric pressure is pressure exerted by Earth. You will be surprised to know the amount of weight you are carrying on your shoulder all the time. It is very huge, nearly 1,000 kg. It is actually the weight of the air above your shoulder. So, isn't it an amazing fact? Here we will be discussing few applications of atmospheric pressure. Aircrafts are always flying at a high altitude and very less air pressure is there at high altitude. So aircrafts are having specialized cabin, that is artificial specialized cabin where to maintain the normal air pressure inside the aircraft. Drinking with straw or injection taking out from the syringe is also an application of atmospheric pressure. When we drink liquid with a straw, the air pressure inside the straw decreases due to our sucking. The air pressure acting on the surface of liquid then becomes greater than the pressure inside the straw. This force of liquid to move up inside the straw. The syringe also works in the similar way. So these three are the application of atmospheric pressure in our day-to-day life. Let's do the recap in a different way. Here I prepared a concept map for force and pressure. Force. The nature of the force could be push or pull, arises due to interaction between objects, can act on an object with or without being in contact. Two types of force, contact force and non-contact force. Force has both direction as well as magnitude. So these are four nature of force. And what are the effects of force? It may cause in state of rest of an object. It may cause change in state of motion of an object. It may cause change in size and shape of an object. So this is all about force. Coming to pressure, pressure is thrust by contact area. So pressure due to solid is the thrust or the force divided by the area of contact. Pressure due to liquids, liquid pressure depends on the height of the liquid column and the density of the liquid, and it increases with depth. Also, liquid pressure depends on the density of the liquid. It acts equally in all directions. Does not depends on the shape of the container. Very important. Liquid pressure does not depend on the shape of the container. Coming to the last concept, that is pressure due to gases or atmospheric pressure, plays a very important role in our day-to-day life, like we are drinking from the straw or taking injection with the help of the syringe. So this is the concept map. Based on that, I am giving you an activity to do. It's now activity time. Here is your activity. Force and pressure are two different concepts, though at times we tend to use these two words interchangeably. Collect some pictures or draw cartoons to bring out difference between the two. Yes, both force and pressure is not same. So you have to make a cartoon or you have to make a cartoon series to show us the difference between the force and the pressure. Do it and submit that to your science teacher. Bye for now. See you soon.